bit so people can respond to this before we jump into it.
You want to start?
Sure. Yeah, so thanks everyone sitting around here. Thanks for coming today. My pleasure to introduce Professor Josh Speagle, who is a professor of astrophysics, astronomy and statistics at University of Toronto. Also my supervisor. Very happy to have him here. This is going to be a very fun talk, I'm sure. He did his PhD at CFA and was briefly a postdoc at U of T before becoming a professor there. So yeah.
All right. Yeah. Thanks, Bill. Oh, I guess I could just do this. Hold on. I'll pull up the standard. Okay, there we go. That's my website. Definitely, I'm an expert at all things HTML. It took actually, I was like, I really want a neural network that turns into samples, and this is what we settled on. I wanted to also look like constellations, so I think it worked out okay. Anyway, so yeah, it's great to be here. Thanks so much, Bill, for the introduction, for opting to invite me over. So this is going to be kind of a pretty free-flowing talk. A lot of my work, both from my PhD and into now, is pretty broad. I'd say that I'm really just interested in the intersection of astronomy, statistics, and AI, which used to just mean like machine learning and stuff, but now it can mean a lot of different things, which I think it's amazing how quickly things have evolved. And more recently, I think in an attempt to get ahead of students, I have just tried to do my best at really getting really deep into what you might call this sort of frontier AI, large language models, vision language models, all sorts of things to just really see how it can be used in all sorts of different ways. And as I think we'll just discuss today, I think there's just a lot happening. In many ways, I think there are things that are unprecedented in making us think about what we're doing. And hopefully in this live demo, we can sort of encounter some of these different things. And others, I think, which are more classical, which are focused on some of the things that I've been looking at recently about how we learn, how we make connections, why are we doing research, what's the point of doing a PhD, ultimately, why are we here at all if everything is just going to be automated soon? I would say that because I'm not quite in the Bay Area, I'm not full Silicon Valley pilled. So this is not going to be like a talk about how we need to be really polite because the machine gods will be here soon. You can if you want. I always say please to Claude. But it's more just I want us to just this to be a pretty open discussion about lots of different things about AI usage specifically for this group, in research, right? Going all the way from undergraduate and secondary education up to what we're doing here as researchers at the cutting edge in astrophysics. So we're gonna see how far we can get with one prompt. So this is gonna be live. I've not run this before. This is a new demo. I change this every time. So the idea is, here's the prompt: come up with a novel research question within the subfield of gravitational wave paleontology, gather the relevant archive literature, simulate or obtain data, implement and test the methods, produce figures, and write a draft paper suitable for the Astrophysical Journal. Verify your results before reporting. This is a live demo, so try to scope things appropriately so we can finish in 45 minutes. So before I get started, how many people have used a tool like either Claude Code or Codex or any sort of command line integration type interface tool for AI before? How do people use it regularly?
Does the chat in a VS Code count, like Copilot?
So I would say let's distinguish that. So how many people have used either Copilot or VS Code or these types of things? And how many people do coding directly from the terminal or from some IDE in natural language? Okay, so there's a gradient. People who aren't familiar, this is Claude Code. I'm not here to shill Claude. It's just what I tend to use. You can do similar experiments and make things like this in Codex and Gemini as well. We're going to use a special setting called Ultra Code, which is otherwise known as dynamic workflows, which gives it permission to spin up dozens of individual agents or versions of itself in order to try and solve our query. So we're going to run this live and try and monitor it. I've given it a pretty permissive set of things to do, so it should hopefully be able to run without much effort. While it goes and engages with lots of things, I then want to just have a lot of discussion, do some live polling, talk about lots of different things, and just really engage with lots of the both excitement and concerns that many of you might have about the use of this technology, both for research, for learning, and other parts of life. Before I get started, I just want to go back to our poll and see sort of where we are like at within people's everyday usage. So in this room, at least, it looks like people are real adopters. So you're using it a lot, often like multiple times a week or every day, at least in the people who responded. If anyone wants to volunteer, like what are some of the things that you have used it for, or that you find yourself going back to use it, these types of tools pretty often?
I can go. I use it a lot for like making specific plots, like very specific requests for plots, like especially labeling, like exosticks, like a lot of the beautification of figures.
Yeah. So you're like, no, I want this line to be thicker. I sort of wanted it to be this 3-panel thing. I want to show this type of stuff.
And I love that you can kind of give a description of like, oh, I just want to move it slightly more to the left or so, and then we'll kind of create it.
Okay, so definitely like sort of iterating around with plots, which used to be some of the most painful parts of like making a paper or figure, having to figure out exactly the matplotlib or like Seaborn style thing. Great. Yes.
I found that it's actually kind of useful for like data reduction in a way. So like different telescopes have like different data reduction pipelines, and like all the code is online, but like it's really hard to learn how to use it if like you don't know super well like that specific telescope or whatever. So like I found it's helpful as at least a starting point for kind of where to start with a new instrument or something like that.
Yeah, so you have like an unfamiliar code base, the tool is able to go through, maybe it's not well documented, you can ask it to help you explore, figure out what's going on, maybe you run a couple commands. Great. Anyone else want to volunteer anything? Yes.
Fixing all the GitHub issues that I don't care to like actually learn Git properly, and so here's my problem, here's my like current states. Here's my Git status. Here's what I want. What do I run in Git?
And it helps to do that. Yeah. So you see that there's a range of like things that are already being that are coming out here. And one of them I'd say here in particular, right, where people are using it is that there's some sort of like end goal that you want to achieve, which is always the thing that we're doing in research, right? We really want to come to some final result at the end. And let's check in to see actually how things are going here. Okay. Whoa. Okay. So it's trying to establish a research direction. It's checking what version of Python is here. Great.
Oh my God. Microfossils?
Okay. So it's now trying to, so what it started doing, just so everyone keeps on top of it, essentially said, great, to answer this question, I first need to come up with a good research question. And so I spawned 6 copies of myself, all of which are going to go and search the web to try and find potentially interesting things that I can use and then come back and form an idea. So that's essentially what's going on. We can, of course, monitor what each of these things are doing. So you can see it's trying to find relevant papers from different things here, and it's struggling a bit to get exactly the canonical formula for astrophysical stochastic gravitational wave backgrounds. But like this is the type of query where it is actually in some ways doing a real like task and trying to get an answer. So one thing I want to sort of get everyone to think about is that this gap between, there is a difference at some level between saying I kind of want things to be this way, and to get there I have to solve all these technical problems. And these models, they have gotten to the point where they can solve those problems for me. They reduce friction. And so that's great when I really don't want to deal with this type of hassle. There are other cases, right, where you might say, in the future, if I wanted to go back to, doing data reduction from this instrument, because I've used this model to sort of help me do this the first time, maybe I have to sort of ask it for help again to do it the second time. And you can get sort of this type of dependency, but maybe that's okay, right? I think one thing that I want to emphasize is that we tend to really underrate how much our own relationship with technology has evolved over time. And for an example for this, right, the type of stuff that's happening that we can see right now, this is in some way the natural evolution of web search and and knowledge acquisition. Before the internet, right, and even before like things like telephones or telegraphs, often like the way that you got knowledge, the way that journals existed was you had to compile them in sort of a central place, send them out to libraries, and you had to learn how to even navigate the physical infrastructure of a library. I am not very old, although I feel older every second. But like there is a point where I had to learn the Dewey Decimal System and how to exactly like, locate certain things based on codes and write index cards and like, keep them with me to make sure I could find my books. In this case, right, we forget that that was a substantial part of what it meant to do research was actually having the skill to go into and keep up with a journal, like go to a library and discuss those types of things. Then we talk about like how this has changed with the advent of Google, right? Now it is routine for us not to remember a paper. We can just always look it up from something like ADS or Google. And the same way that back when writing was first invented, I'm trying to remember if it was Socrates or Aristotle who was like, oh, now that you write, you won't remember anything anymore. It's like the death of all knowledge and thinking. And no, it made me laugh, but like it's the same, like there are many things that we don't remember how to do and that we are reliant on technology, right? Astronomy used to involve a very different set of skills than today. It used to involve us being able to go out, tell the exact location of stars to pretty high precision, being able to tell their magnitudes and brightnesses to pretty high precision, and being able to sketch their positions in real time throughout the entire course of a night, right? Like live. That was how you did science, and that type of navigation was very important. I don't think many of us can do any of those skills. Some of us might be who are very avid, what we might call like average amateur astronomers might be able to go and do some of these things, but I don't think any of us could navigate this way or at this level of skill. Is that a problem that we now are very dependent on technology and a different way of navigating the world? I think it depends, right? Especially if we might lose that ability to do that by launching up 20,000 Starlink satellites, and then we will be forced to navigate the world in a very specific way. This is, I think, one of the challenges when using these things is that this is the type of task that normally we have to do. Our relationship with how we approach science changes once we have easy access to things like search. That idea that, oh, we should add some more references here. And the idea is, what references do we need? I don't know, but we clearly need some to like back up this claim. We should go look it up, right? That's a crazy opinion to have when doing that particular task involves like weeks of work and you really have to go through and plume the archives of a library. But now we can have that attitude because we have access to this type of stuff. Now, if you want to do detailed background research on an area, you have access to a full suite of AI models that can go and search the web for you, doing hundreds or thousands of web queries, hammering infrastructure in order to do something, right? The scope has increased as the capabilities have gone there. So it's always one of the points I want to raise in this talk is that there are many ways in which we look at technology like this and act and feel like something fundamental is changing. Well, also it's important to recognize that this sort of march of technological progress and change in our relationship with technology is one of the foundational aspects of being human. So that's where I want to start, right? So the question I now have is very much focused on this for everyone. So let's do another poll. So for people who are using these models, when it comes to how you're using them, for people who are using them or who tried it, how do you feel that how much did you learn from that test, right? How confident are you that you could explain to a colleague right now, like the last topic that you're using AI to help you accomplish? And so we can see already with like the set of respondents that are here, at least in this room, people feel that they are primarily using these models in areas where they have a lot of expertise. Is there a reason why this, for people who feel pretty confident, if someone wants to describe like what was the last thing that they used it for or like how they were using it, that would be great. Otherwise, I can definitely give an example.
I think for me, it's a lot of like pseudocode. So stuff that I would be able to code up if I needed to, but it's just like exponentially faster to give it a prompt and get it to like create some set of functions or some pipeline or something.
Yes. So coding, I think, is one of the areas where these types of models have transformed our relationship with technology in like a pretty big way. Okay, great. It's now actually doing updates to, it created a little library for us. All right. Well, we'll see what it does in a second. I'm just gonna refresh this so the terminal actually is working. Okay, so apparently it's trying to get noise calculations here. So let's see it continuing to cook as we go. Okay, it's trying to run MC as well, so it can run faster. All right. I think this is exactly the case. So Phil, maybe I can ask you a question. If instead of giving the model the pseudocode to write it up, you actually had to write it from scratch, do you feel like you'd be a bit rusty, or that you're still pretty confident you could do it like without any help?
Well, I think like, I don't know, when I used to code more by hand, I'd always go to like Stack Overflow with like documentation or stuff anyway. So
Yeah.
I think with that, I'd be fine. Without that, like that's the level at which I always had resources available to like help.
Yeah.
Like I never had to literally memorize every function that different libraries could do. So going back to that level that I learned at, I think would be fine.
Exactly.
Yeah.
So I think this is sort of what I'm getting at, is that often in areas where we have expertise, that is the easiest one where we feel the most comfortable delegating to these AI systems, right? Where we go, look, I know what I need to do. I have a clear vision in mind. You know, here's what I want. Okay, like this is very technical minded. I don't really want to get into the weeds here. And I could do this if I needed to, right?
Yeah, I think maybe one thing would be curious about, because I feel there's kind of three levels, right? Like there's one level where like, okay, we know how to do it. It just would take us a lot of time, like, reproducing some plot, or like, oh, can you make an interactive version of this plot? But you can kind of check the results. Like that's, so Claude gives you maybe some code, but then you can like check it versus like your own estimates or your own calculations. So there I'm very confident, right? Then there's like this other way, which you're doing now, which is like, okay, it goes completely from scratch, like come up with a question. Like, so it's really like Claude is like doing, it can kind of also maybe choose a question that it's better at. Like, I don't know if it's not actually good. But then I feel like there's this intermediate range where actually I wish it was better at it, and I would love to trust it, but I just know from experience it like doesn't, right? So like sometimes I'm like, oh, can you give me an overview of like all these different rates from all these different papers or so? And it makes like, where it's like, oh, I would love to trust it that it can actually accurately read out plots, values, and so on. But it's still at the level I find when I do this where like I see that it's giving me back like bad results. And so then I'm like, okay, never mind. I cannot use you for this specific task or so. But I'm curious, like if maybe it does it from scratch, or had that same task, but then really from scratch rather than halfway from me, if it was like better at it.
Yeah, so I think like, and you guys, I mean, the idea here is to just show us going through this in real time, right? That what we're describing a lot are many of the ingredients that come in with doing research. The bread and butter of like, we kind of want to do you want to go and scrape the literature, you want to go and do this, I'm the one who's generating all the ideas. I still have to write the paper. Yes, maybe it wrote some of the text. Yes, maybe it wrote some of the figures. At what point are we in like a ship of Theseus, where essentially all of these tasks that by themselves feel like very much like we're in control become at the point where it can be fully automated from the beginning, right? And we are getting, the idea, at least with this demo, is that we are getting to a point where this is now, maybe we consider this a risk, but definitely something where you can ask like, well, what is the thing that we are doing? Like, why are we here doing research? Why are we here to learn? Okay, apparently it was very happy that it confirmed its forward model was correct, and that MCMC recovered the fossil redshift, apparently. So I think this is sort of where I wanted to just ask people, like, you can see this happening in real time. Like, I think, would any of us, actually, maybe this is a good point. Do any of us feel like this is not in some way like thinking or clearly acting in like a deliberate way? Would anyone feel like this is just essentially some stochastic random parrot performing actions that doesn't have like a clearly defined outcome or goal? Yeah.
So I think the question was, does anyone think it doesn't do that and it's just spitting out stochastic stuff, right?
Yes.
So it's converting everything that it's doing to English and trying to make evidence-based reasoning statements, right? But that is not what it's trying to do at the back end. It's just the thing that it's learned, or like what is it, a model to do.
Mhm.
But in the back end, it's just doing some random things and it's just working out for it.
Mhm.
It's just another, okay, this is the inputs, this is the outputs, this is what I learned.
Mhm.
So how can we actually assert that that is the process of learning?
Yeah. So,
Maybe an analogy I could draw
Yes.
was like, we write code in Python, C, whatnot. The stuff that goes on in the back end is a bunch of machine language, assembly
Mhm.
language. And those were robustly built up. But nothing was robustly built up in this regard, where you didn't tell the model that this is the process of evidence-based reasoning in each and every something that it's doing.
Mhm.
But you say that that's the framework and use this framework to and apply that everywhere. For the how can I be sure?
Yeah. So I think the reason I always like to ask this and is to engage with this is that if this type of evidence isn't, at least for you, is not sort of signs of like this type of action, what are the specific things that we do that is different from this? Uh, I'm very fortunate to have like a young kid at home, and I can see him learn every day, often very efficiently, how to do things if he wants to. Um, and but the question is like, what exactly, if if the entire point of this system is just to mimic humans, and what it just is doing is some complicated operation that says, what is the next, word that I should generate that somebody who is trying to be a helpful AI assistant who is very good at coding and also a thoughtful scientist trying to answer this question and come up with a thing would say in order to answer this question. Um, is that essentially at some level the same as how we approach the world? Just a little differently. Yeah.
I totally buy this idea that, these things are learning something very deep. They're like questioning what it means to learn at all, which is great. But going back maybe to Phil's coding example, like I agree, it's fine to use code from Stack Overflow, right? And to use these tools to code. But part of that is because we're not, at least, okay, let me say personally, I'm not a computer scientist. Like nobody's staring at my code line by line and like questioning my style, questioning my choices. Like if that was actually the case, right, then probably the way I would interact with these kinds of things would be very different. But so that part is fine. But let's suppose you produce a plot with these kinds of agents, and then you give it to your advisor, your collaborator, and they said, "Oh, this doesn't make any sense for this reason. Like I don't understand this particular thing. It might be a bug in the code," and then you don't understand it. At some point, you're going to have to go and look through all the code and understand every line to understand where that bug came from. So I feel like there is a kind of bottleneck, right? With this, at some point, you can't speed up the understanding process.
Yeah.
Is
So
that fair?
yeah, no, I was going to say, so I think we actually have two different questions, which are some of the points I want to outline here while we're watching this thing, like trying to make lots of plots. One is to your line, this bottleneck question, because there's an assumption here that the student will be the one having to check this and send it to the advisor. But from the advisor's perspective, like if running this, at least if I was billing on like, whatever Claude is giving at its very expensive API, probably this entire exercise is going to be less than $20. Why would the advisor not say, why can I just kind of cut out the middleman and just directly talk to the models and tell it to go and review the code and try again because these things are there? Why does the grad student have to be involved at all?
It depends, I guess, on your role. Like,
Yeah.
What do you see your role as an advisor? Do you see it as just to produce results or to train scientists?
Absolutely. And similarly for the students involved, like what role do they want to have in this world, right? Is it to essentially ask a bunch of AI to do this work, especially if they can do it faster, more cheaply, pump out more papers, right? Help you get a job. What should you be doing as a student in that respect? That's one side. I think to get to that, the second one I want to ask is, so how many people here actually interact sort of regularly, either teaching otherwise with undergraduate students or undergrads themselves? Great. In your sense, do you feel like since the advent of ChatGPT has come on the scene, has student interactions with you and their performance gotten better, like they've become much more thoughtful, on average, about the same or declined? So I'll just raise a hand for how many people feel like that in general, you feel like students you interact with, they've gotten like way better, way more thoughtful with access to these tools. Then it's about the same, like it's a wash. They seem about the same. How many people feel it's gotten a lot worse?
I think both.
I think it's bimodal.
Yeah.
Bimodal?
Bimodal, yeah.
Yeah.
So I think like people were like stressed already or like don't really know how to really get help or resources. Now it's even harder to kind of ask humans or like learn how to study or so when you have access to this. But then it can also accelerate like what you're learning, I think, a lot.
Yes. So I think this is, sorry, did someone else want to add something? Yes.
Yeah, I just want to say that it kind of also depends on what kind of evaluation you are giving to the students.
Mhm.
If it's like a traditional closed book exam or even an oral exam, then those who heavily relies on LLMs might not performing as well. But if you're thinking about evaluating students with like the scientific progress they made in their projects or whatever,
Mhm.
then it's probably that will get better compared to the pre-AI era.
Yeah.
Oh, well, I'm not a teacher, but I feel like also it depends on how you use the AI because like it's the same thing as like looking at the answers for homework, right? You can like just write down the answer and return it in. You can like actually study what the solution is. You actually understand what's going on, so that you know what to do on the test. So like if you like use the AI and actually like look at what it's doing and it's like using it to like be more efficient, I guess. It's different than just like writing down the answers and trying to.
Yeah.
I think it's the same point that you made before. It's whether they're using it to help their understanding or to replace their understanding. That's what I mean. I work with students for research, and the ones that just use it without questioning what it puts out are the ones that struggle more, and the ones who use it to improve their understanding and like ask questions, simple questions to that, and the complicated ones to me. They are the ones who are excelling.
Yeah.
So yeah.
So I think this is actually very much what some of the research is showing. So I'm just going to pull up this. This is an infographic I made. I can send around this link to this Notebook LM, which has a bunch of resources on AI education and learning. But I find this is a good place to start. So in general, this is exactly true. The promise and perils of AI is that they can really accelerate your usage and learning, but it's very, very challenging. And that's for a couple reasons that are actually not a surprise. So the biggest one is that we are terrible at assessing our own learning, which makes sense because when we are learning something, we're not experts. We don't know what it means to understand, right? We are really bad at doing this like uniformly, everyone. And so what that means is that when you are learning, often you learn best when you have some sort of guidance for how you're going to approach things. But most importantly, the other aspect of learning, at least for humans, is that learning is fundamentally hard. I don't mean like it has to be painful and we, got to weed everyone out in like super intense classes for no reason. I mean that we really learn and sort of acquire deep knowledge that we can recall and get expertise by often getting things wrong and being cognitively challenged. So by having to really understand something, explain it, work through problems, get them wrong, but often not just get them wrong, but get them wrong repeatedly over a long duration. So there's this act of sort of learning and forgetting where every time you engage in this extra process of retrieval, where you've forgotten how to use that knowledge, you have to bring it back, then deploy it again. And then every time you end up going through that challenge, you learn it a little bit better every time. So this is sort of foundational study of learning and skill acquisition. However, it is not necessarily the way that you maximize your score or an evaluation on most metrics. To do that, it's actually way more effective to cram. So our short-term performance from cramming or things is quite high, but our long-term performance really, really suffers. So if you're always looking at essentially trying to do short-term gains, you start to see like lots of the incentives for both students and researchers is not good. So if your goal is that in order to be able to succeed in the field and get a job, there's lots of pressure, right? Everything is competitive, especially now when the government is essentially shadow banning science. you essentially are like, well, I have to be even more competitive. I have to produce more things. Nobody says, oh, I'm cutting corners, I'm a bad person, but everyone says I can be more productive, right? So what I'm going to do is I'm going to use this skill and I'm going to cram a lot so I can get that paper out faster, right? So I can do this type of thing faster. The quality doesn't necessarily have to go down at all. You can still do very well, but the amount to which you retain the information and are able to use that 6 months in the future, that does go down. This has like been a known problem in higher ed forever, right? How to align learning goals and incentives with grades. Because in many ways, those do not align very well. And this is something that AI has supercharged for all of these reasons. So the idea is that when you're pressed for time and you want to get that answer, these are frictionless systems that now have acquired enough expertise that with basic work from your part, you can get those answers back. And if you want to then go deeper, you have to exert more effort consciously, which means, right, that you have to actually somehow really like feeling dumb, which is not something that most people do. Like most of us in this room, we're like, yeah, we love feeling like idiots and we love learning new things. But for most people, that's not the goal of their life, is to feel stupid all the time. And so if you're sitting there and you go, well, I bet that person is using AI, and so I need to do better because everything is getting more competitive and they're, writing better emails and better essays, that incentive is very strong, especially when you're looking at trying to do well on assignments, do well on exams, right? Also in research, the incentive is really high if you're only looking at publication qualities and citations and these things, right? Those reward output, not necessarily like very high quality. Now it says other knock-on effects as well. In general, there's some really fun studies that have been done, which show that actually some of this efficiency isn't even real. So one of the best things about this is that our sense of time is very fuzzy. So when we are waiting for like a bus or somebody, often there are studies that have shown that we sort of feel that every minute is as painful as 3 minutes. So like a 5-minute delay feels like a 15-minute wait, or just like 15 minutes of just going or doing something else. When we enjoy something, it feels shorter. And so with AI, this actually hits us on both directions. The sort of sense of when it's acting autonomously, we tend to discount that time. And the time that we spend prompting, we tend to ignore almost entirely. So when people feel more productive using these models, it's because they forget all the time they have to give a response back. And in general, in some tasks, this prompt overhead can be as large as 30%. This is from a study from Anthropic earlier this year by Shen Tamkin, which used this to essentially have a bunch of programmers learn a new language, and found that not only do they spend more time than they thought prompting, so even though they felt more productive, their actual productivity gains are about 0. They had lower cognitive load in general. This is from separate study about students using ChatGPT to like write an essay and under a brain scan. But they actually did much worse on assessments and had much worse recall, right? And in general, this isn't like for a taken forever thing. There are actually ways in which there have been studies shown that under the right circumstances, especially when models are trained to do sort of like Socratic method, where they're never giving you the answer, like they just constantly rage bait you, because they're like, oh, you want to do this? And you're like, no, I just want you to tell me. And they're like, I can't do that. Maybe you should think about it harder. Brings back memories of my undergrad. There's one prof who did this during office hours. It drives me crazy. But that's essentially like where people have found that there are gains, right? Where essentially it forces you to have to work really hard to define what exactly you're looking for, to actually get through your understanding, explain it, go back to you, often across multiple chats. It's a lot of work is ultimately what I'm saying, right? And that work means that maybe if you're really targeted, you can actually learn more and quicker than people who don't have access to these tools. But it also requires a very conscious effort and really good, what I would call like learner hygiene, the same way that we try and practice good sleep hygiene or good health or nutrition. Like you have to really get into this habit of always approaching problems a certain way and interacting with these models a certain way. And the takeaway that I would say is that often when you're working with AI, it should not feel a breeze. It should feel exhausting. Like you should leave after 2 hours being like, oh my God, like because you've just been like on the whole time, like just trying to really think about what's happening. You should not do that all the time, but I'd say for learning, this is something that has come up a lot. It's also endemic. I think from the last numbers I saw, like effectively 100% of students are using this tool at some level throughout education, so they use it a lot. And so it's just something that we need to keep in mind, that given the incentives are here to produce more and always to, and that there is not really a good way of sort of rewarding deep understanding instead of particular output of what we say should be a product of understanding, this is going to be a problem that AI will supercharge. Yeah.
Maybe I'm misunderstanding. So is the chart saying more or less that the 30% offsets the apparent like 32% or like?
No. So this is saying that roughly, often for some tasks, you can spend as much as a third of the time prompting. So that's where the model's not doing anything and you're just thinking of how to respond.
Yeah.
And in addition, when doing certain tasks, you're actually having a lower cognitive load. This is measuring brain activity. So you're not thinking as much and you are spending time that you don't think about very much. And so both of these often are what you can see as factors that contribute to people essentially losing most of their productivity gains. It sort of feels easier, and you feel like you're going really fast, but then you don't actually understand as well. And so that means that the skill that you would build up doesn't happen. And so you perform worse over time and need to rely on these tools more, and you discount the time that you're using them. And so that can often lead to a lot of firms, and this is documented, getting smaller gains out of AI than they expected, is because you get this sort of into this pattern of dependence and also like over indexing on how productive you might feel you are. So that's at least some evidence. If you want references, they're in there. But that's at least I thought this infographic was a fun way to code this on this side anyway. Do people have any like questions or thoughts about this? Does this align with what people's feelings are? Have people tried to use models this way more actively for learning? Yeah.
I don't know if you had a question or this is like a.
No.
Okay, sorry.
We're probably gonna see how we're doing on the paper.
No, I just wanted to say that also we have like an AI like center or help person here at like UCSD, and they gave like a recent talk. I think they also have spoken for the grad students at some point. The one thing I found very cool about when they gave this talk, so her name is like Tracy, I believe, is that she also showed some examples. She had some like videos of like how is a student when you're like on campus or when you're using like Overleaf or like when you're just using like your usual tools, how basically everywhere companies are throwing AI at you. So
Yes.
It's like not only is it like
Yeah.
most students are using it, but also like most students are really encouraged by these companies that are
Yes.
trying to target like students who they know, are just stressed and like vulnerable, but also like, oh, if they sell it to them, they will probably stay to it and maybe tell their fellow students to also. So it's like a good money making strategy. But so it's really crazy where like even if you're trying to type yourself, you'll have like a bot come in and be like, oh, let me fix this for you, let me fix your email or fix your grammar. So it's like, I think that I find it a little bit annoying, but
I mean, at some level, I think this is something that we all feel, right? What are the things that we're like, I wish that AI could help me write my emails. And then someone's like, I wish AI could help me respond to emails. I think the number of emails that I've seen where there's extremely flowery language and specific bolding, right?
Yeah.
There's a great paper that came out recently about how heavy LLM users are like, as a consensus, like as a committee, like 99% accurate at detecting LLM text. I know this for sure is my case. I can tell not only is it LLM text, but often which one produced it because they have slightly different, styles. But being like, oh, I want it to help me write emails because I want to send more of them and like get, higher chance. And then, the people on the other end are like, oh, I kind of want to have AI summarize my emails. It's the most lossy form of compression, right? Like you write a bullet point, it turns into a long paragraph, and the long paragraph gets compressed back to bullet points. This is like LinkedIn now, right? You have all these AI like producing resumes and automating jobs. And then of course, now all the companies have too many applicants. They use AI to screen for the jobs. When we're looking at papers, look, we are witnessing, this paper is done. It's done, right? Like it's just being checked. It's running a review to make sure the paper's not crazy. That's what I'm saying. Like it is, we can see that it's not, this is an AppJ paper, like in the correct style. It's maybe not amazing. It's very short, but like this was done in 30 minutes. Like if you could ask like, well, what if I spent a day on this? Like maybe this could be a good paper. Even having that thought is crazy, right? Like that's my point is we're potentially going to enter, like we might say, oh, we don't want to do this. Someone's going to do it, right? Someone's going to be like, I can author 30 papers a year, right? And then once someone starts doing that, what's everyone else going to have to do? And suddenly you're gonna have too many papers to read, and so you're gonna ask the boss to summarize the papers for you, right? Like I even wrote a tool to do this because I am so overwhelmed. I have the bot summarize papers for me. Because in CS, there are like 300 papers published a day. Like it's too much, right? So what are we doing? We have LLMs write the papers, we have them read the papers, they summarize the papers for us. Like, why even put them in English at this point? Like, why? So what I mean is like we're entering this era where like the people who are winning, like all the slop is being generated everywhere, right? Everywhere online, everywhere in person, right? We're seeing so much of it. The internet now, I think, is over 50% bots by some estimates. So we are in an era where like things are being produced and consumed primarily by these tools, and the incentive is just always to produce more, right? So one point I want to raise here is that given that this is possible, and like you saw this happen to some level live, and Floor will give everyone's feedback on how bad or good the paper is. But like the fact that like when I first saw this, it was a thing where I realized that I could not just like auto reject this. I would actually need to like at least skim it to verify what's going on. So, but it's more just trying to flag that now that these things are possible, like what ultimately is the point of us being here and learning and doing research, right? Now that we're here, especially, and where are the incentives that are outlined that just everything points to people wanting to do more of this because you got to get more papers to be more competitive. You got to go to more meetings. You got to get more citations, right? If you're a student, you got to get higher grades. You got to go into you want to use AI to like maximize the amount of time you're doing so you can build your app and you can, try and make a startup and you can respond to like three email inboxes at the same time while you go get a burrito. Which you then like sell, which you then do a buy now, pay later, which then gets, auto packaged into some secure burrito back security. Like, this is like the world that we are creating for ourselves, is my point, right? We are creating this world for ourselves. This is an incredible like achievement. I mean, don't get me wrong, right? Like this is great. But it's more that I think given that this is now possible, we should be very, very deliberate about how we want to use these things in our lives.
Would be very happy when we get an email with typos.
Yeah, until you realize that probably someone asked the LLM to make typos because they realized that seems more authentic, right? I just enjoy getting a sick letter, which was like insert symptom here. That was good. I forgot to deliver. So one thing I want to flag here as well, do people have questions about this? Then I want to talk a little bit about ethics.
Yeah, there's also a couple of comments from Greg, like
sure.
in the chat. I don't know. I can just read them. It was just based on like some of the previous messages. So yeah, mostly saying like, asking experience with asking AIs about novel form of R&D organization. And it came back with super detailed and super complicated comments. And that, indeed, like you probably had to be like a lawyer to understand it all. And it's like, how do you deal with just so much information? Yeah.
So I definitely want to leave some time at the end for us to talk about what the future might be. And I want to be proactive because I'm not here, like I would not be here telling people to be like, why do we need grad students? Why do we need to exist? Or like we should just automate away everything. Because I don't believe that we'll have a nice UBI at the end. But I think this shows that like there are all the incentive structures right now, at least in both research and academia and in sort of higher education, are aligned to get people to use these tools and to use them in ways that are destructive to learning. That doesn't necessarily mean that they're destructive to actual like research deliverables, right? It is very likely that we will get more actual science that is done using this type of thing. But I think it's important to ask like why we are doing that science and what the value is of that science being done by and for humans and for us, right? Like, at some level, these models only care about astronomy because we care about astronomy, right? David Hawk has a nice position piece on this, which I really enjoy.
We discussed it actually,
Yeah, like I disagree with David on on some technical stuff, but I agree with him very much so on like, if you ask why do we do astrophysics, I think the answer has to be that, we care about the scientific community, we care about producing results, and like we care about it for people, not just because we need to produce more scientific output. Like, especially in an area like I'd say astronomy, which is in many ways, this is my opinion, I think closer to art than to like, cancer research. I think that's something that we're privileged to have the ability to think about, right? Okay, do people have any questions about this type of thing before we move on to talking a little bit about some ethics and then maybe talking about what people feel like would be the future of how they want to see themselves using these tools, like as a PI, as a postdoc, as a researcher, as a student? Yeah.
I guess I'm not a philosopher for sure. I'm not a psychologist at all. But yeah, related to what Flora was saying, we had a discussion on David Hogg's paper, and we thought, what is the ultimate limit of this? Like the ridiculous, like totally nonsensical limit. And sort of someone brought up the Hitchhiker's Guide to the Galaxy.
Oh, yes.
Right? And
yes,
you have the supercomputer that basically you ask it the question, what is the meaning of everything?
Yeah.
And then it spends some time, right?
Well, we actually don't know what the question was, is the problem.
Yeah, that's true.
That's right.
Good. Yeah. But anyways, maybe there's some agents looping and doing stuff.
Yeah.
But then the answer was 42.
Yeah.
And it's great, but there's like a very unsatisfactory kind of sense. You didn't really understand.
Yes.
But I feel like in that limit, isn't it clear sort of like the reason we do science partly is because we want to understand things? Like there's an innate curiosity there. Like at some point, someone's going to be like, why? And then they're going to want an explanation for it. And then someone's going to have to provide an explanation. And I don't think you can get around that.
So I agree that I think as a foundational principle of science, that is true. But, the question is like we, as a society and as a people, we do have many areas in our lives where we are willing to essentially forego that question and just deal with the outcome of that question. Asking a lot of people, for example, climate change, right? If you ask someone, well, how does the greenhouse effect work? You ask a random person who says they believe in climate change, they usually don't know how to explain what the greenhouse effect is. You ask people how you lose weight, people don't know how that actually happens, like how exactly it's metabolized in the body, So this type of thing is actually quite universal. Like not all of us know exactly how like band gap, like in semiconductors work, exactly how machine code is designed, how NVIDIA designs chips, how these deep learning models operate, and yet we're okay using that, right? Or even how search works. So I think that definitely and the outcomes of some of this could be like life-changing drugs, right? So there is something where some tension where you say, look, the output, if it makes our lives better, it's really important. And maybe we don't need to know as much. Not everyone needs to know everything about it. But I agree that actually, as a fundamental principle, it is good to say like, well, understanding really is important here. Yeah.
So I totally agree with the point. Maybe I'll push back a little bit and just say that I agree that not everybody knows everything about everything, right? But there is someone as a society, right?
Yeah.
There is someone who is an expert, right, on the algorithm. There is someone who is an expert on like search engines.
Well, but you can see it compared to like expert on like magnitude of stars, right? Like being able that skill that like what Josh was talking about. So that person doesn't exist anymore. The person who can like read out the magnitude of stars. So
Yes.
I think there's some. I agree with you, but I think there's some.
Yeah, I'm trying to be provocative here. I'm approaching this as a humanist. Like clearly my position is I do want us to exist, like both as a field, but also just as a species. But yeah, I think that's at least this should hopefully show you like this was done in 40 minutes and probably get it done a little faster if I responded to some prompts better. And this is apparently what the key results from this paper that they tried to do for gravitational wave paleontology. But the point is like if you can do this in 30 minutes for like $20, you could easily imagine a version where you do hundreds of these, like and just try and churn through them, brute force them, select the best ones. You could have students do human review where you just give them dozens of papers every day and they select the better ideas, write some comments, and then feed it back to the machine. And this would be a new way of doing research where all of us just rubber stamp good AI generated papers until eventually we get the best AI generated paper after thousands of trials. And this might be more cost effective than feeding a person because, living wages are expensive.
I also really wonder if like maybe in some ways this encourages us to do better science, as in like, okay, we can maybe even there's so much like so easy to write a paper. Maybe we really have to like, sit down and think about like what is really like novel or how can we combine these things and really come up with like where do we go next? Which I think these programs are not so good at yet.
Yeah.
Rather than like, okay, here's just another quick paper that like an AI could also have done. So I
Absolutely.
think that's like a somewhat good thing that like we don't maybe have to write 100 papers anymore, but we can care more about like developing skills and like specific, one really good paper that we know really well how to present and so on.
Yeah, no, I think this is so this is definitely the type of argument I think that the field, like we as a field should have, and that this should hopefully show people that you guys all got to see this run live. This is like a real ability now that these models can do. And I can confirm like the Fable model can also do this, and the papers it produces are better than the current one. Like it is actually, it came up with an idea where I was like, huh, that's quite interesting. And I started reading through it, and some of the results are phrased a little funny, but it actually was something where I'm like, I could run with this. But yeah, I mean, for example, right, like everyone talks about oversubscription to JBUST. If you just told people like, look, you just have to author one proposal, it has to be really good. Like, I think that would change a lot of the dynamics about how people use the instrument. If you told people that they only could write one paper a year, but it had to be a really good paper, I think you would see a lot of, or that when you're reviewing somebody for a job, that it doesn't matter how many papers they produce, you only can read 2 of them, right? They select the top 2, and then the committee has to read those papers, and that's it. The dynamics are very, very different in that case, for how this ends up going through. Yeah.
One of the things that I find really interesting about this is there's the whole replicability crisis in science.
Yes, this makes it this makes it both better and worse.
Yeah, but if you can take a paper and have a model replicate their results from a data set,
yeah,
that could be a very interesting check on some poor quality papers on the publisher side.
Absolutely. I mean, you could even say that this could be done automatically by publishers, where if someone submits a paper, it tries to spin up a model that replicates all their analysis, or at least the main points of their analysis if the data set's too big, using some summaries. And if they can't do that, it then can identify what areas were unclear and what assumptions it had to make, and it throws it back to the author. So you could totally do that. I mean, you could also have this help with language. Papers that are being submitted now, you could definitely say like, look, there's a lot of non-native English speakers who, especially for things like AppJ in China, for example, there's for lots of governmental reasons, it's been elevated to sort of a tier 1 journal. So there's been, I think now at this point, almost 50% of papers submitted to AppJ are from China. And so you can imagine actually building tools like this, especially because LLM users who benefit the most from this tool, who report benefiting the most, and who show the most, positive engagement, are those who are using it to really help improve their writing. Right? There's other ways that you can say that we could use this in a really positive way to improve how science is done, to improve the papers that we read, and not like this. Yeah.
Would you say this increases the importance of like having open shared data sets and code repositories?
Yes and no. So I think that actually, I definitely am a huge open science fan, but actually one of the areas of science which is being filled with this type of slop is exactly public health, where they have lots of big shared open source data sets. And what people have done is they've essentially, because of all these incentives, there's now been a huge increase in people using these models to just do, let's try every correlation possible, because now I can do every analysis possible on this data set. We're going to slice and dice it. And so there's been a humongous increase in papers submitted citing those particular data sets. So that's what I mean is like, you see that because the incentive system is aligned this way, that this is sort of the outcome that we get for things that are open and public.
So the problem is the incentive system.
That would be my argument. I think that these tools can have incredible promise. I mean, this I think is amazing for, you could imagine doing tons of ideas and getting feedback back on them really quickly. I actually have found, to Phil's point, some of the best uses for this now are when I work with students, I just say, look, just write up whatever, and then when you're done, just send me all the code in a giant file that's a mess, and I will have the models help clean it up. Like, we're going to go through, we're going to tidy everything, we're going to write documentation, and you don't have to worry about this because this is not the top priority for your science project. But it's great for then being able to have that final thing afterwards to give to someone else and to understand what was going on. Okay, one thing I want to flag before I finish, just because I think this is really important. This is not a neutral tool in the sense that, using these models, the same way that, using a smartphone, right? You are benefiting from a system that has done a lot of things to people in order to bring you a very shiny gadget that you can use to be hey, I'm interested in burritos, and then it will pull up some random burrito places, nearby, right? I just want to highlight one in particular, which is that there is a growing and very clear gender gap. Also, this article is wild, by the way, because this is how I would have phrased this problem.
Yeah, like women are avoiding AI, like.
No, so it's true. So this is a true thing, and they've actually done follow-up on this that shows that this is actually now a pretty clear trend. In terms of AI adoption, AI usage, and feelings about AI, women are tend to feel more concerned about it. They do not feel as positively with it. They're also less likely to use it, even controlling for availability, access, and training. So lots of the reasons they report, you can actually go through and read some of the working paper. There's actually quite nice work by, this is one of the authors, there's like a team of them at Harvard Business School, but they've actually tried to do some meta-analysis and it's quite interesting in terms of why there seems to be a large and now persistent gender gap that's emerged in many different areas. This is true in like entrepreneurs, it's true in school, it's also true in academia. So like this seems to be a pretty prevalent effect. And the main thing for often why there's lower adoption, especially among women, when asked sort of what exactly are the top concerns, there's a lot of concerns about accountability, about what will happen if something goes wrong, like that I will be blamed for this. There's lots of worry about if it makes a mistake that they will also be seen as like dumb or incompetent for relying on these models. And so you can see lots of these societal biases that are in many ways common in many societies are starting to make their way into usage, adoption, and feelings about this technology, which is very important to address when this is being in many ways heavily encouraged to be used by everyone. That there are real ethical concerns in that if you are not careful about this, just like in computer science, there's a really long and persistent gender bias that has its roots in many different historical things that we're likely introducing the same thing when just talking about AI usage in general. So I just want to flag this because I don't see this discussed as much, but my guess is that if everyone here thinks about who's like the biggest booster of AI that they know, most of the time it's not a woman. And if you think about who the most skeptical people are, usually it is a woman. Again, this is not meant to make a blanket statement, but this effect is significant. It's like on the order of 10%, which is quite large if you think about voting, #election.
So you're saying it's like closer to like 60-40.
So I believe it's like 55-45, but yes. Yeah, but that's right. But yeah, this is like a persistent effect. So this was first documented. They did some very interesting work, and then there's been some follow-up papers. They had a brilliant article related to like looking at this in the EU, where this appears to have leveled out and become quite and stabilized. Yeah, so it is like at least a few percentage points, and depending on the area, the effect manifests in different ways.
And I think, of course, the other like bias is like, I think it will still rely for like, for instance, like, oh, what papers do you cite when you want to make a certain statement? It will like rely on like, okay, where is this citation often used in like other papers, right? Like it will kind of rely on this like library of like papers and citations of papers, and those of course are biased because they're like, in lots of different ways. Current papers, as people have shown, are like biased in like who they cite, what they cite, when they cite, etc.
That's right. So all these get baked in, and this also goes into the models themselves too. There have been several nice studies showing that even after there's been lots of like reinforcement training, learning to essentially try and like really beat out biases along lots of axes, this is like a sieve, so it's very porous. And those same biases often find a way of manifesting in other contexts if questions are posed differently or if things happen differently. For example, like if you have a conversation about like, blah, 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 and then something woman, and then you ask for like the color of a car, it will often be different than if you had just had a conversation about like a man and then asked for the color of a car. So these types of things happen. I've had multiple exchanges where like out of nowhere, for example, Bob would be like, what do we do about the fact that like you're on parental leave and someone might feel you're not as competitive? And I'm like, shut up, But like this happened multiple times, right? And they're clearly responding to like a real concern that has been displayed in academic review that comes from a place, and often it goes, oh my gosh, you're right, I was being like terrible, but like that's the point. It's like these systems are often the same things are being perpetuated no matter how much you try and be like, we're going to control for all these different axes. So you must always be aware of this and use it to your advantage, right? These tools are not neutral. They're not built to be neutral. They're not like ultimately neutral. There's I don't have it up right now, but there is an amazing blog post by OpenAI about how they're thinking of making their models politically neutral. with an audience of one person. But like if you read through it, it's a wild like attempt to be like, how exactly do we even answer that question of what politically neutral means? And it's a very interesting approach. Yeah, so that's again, I just want to highlight this to say like these things do come up both in practice and in usage of the tool. Yeah.
We're very close to time, so I'm gonna say let's give a big applause to Josh for nice job. Don't hesitate to like maybe you have to go to another meeting, but in the meantime, if there's any questions, feel free to ask them now to Josh. Questions or comments or curiosities.
Yeah, and if anyone wants to review the paper afterwards, I think Laura will get to do
we'll
that
get-
as well.
We'll
to
get
see
this
how
stuff
good or
in
bad it
the
is.
recording. Back to you all. Thank you. And take some pizza. There's still some pizza.
Yeah, I have a question about, so like for maybe a couple of decades now, there's been an inflation of the number of papers that you need to get into whatever position, whether that's
Yeah.
a student or teach or
Yeah.
stuff.
Yeah.
I thought for Hubble that's not true, right? That like the Hubble that actually like the median hasn't changed so much. There's just like a large stigma.
I think the last time they looked at it was before AI.
Yeah.
So I would be a little concerned if we did an analysis
Yeah.
again today or like in the next 5 years.
Science workshop.
There's actually a
Yeah.
Lisa Cooley's like investigating right now.
Yeah.
Astronomy fellowships in the US and North America to see like what's the number of papers and like other meta data. But yeah, I don't know if that's what you're thinking about.
I'm thinking about like whether it seems like this fully agent level of usage would make the problem worse.
Yeah.
So are there people thinking about other potential ways that you can use to evaluate the
Yeah.
performance of a applicant other than the number of citations or whatever?
I think that's going to be the problem, right? All of the metrics that we use to evaluate performance. This has always been a problem with learning and assessment is that, there's some fun, like, I forget in like business school, they come up with all these fun names for these. This is the one where like, as soon as you create a metric, it ceases to be like meaningful. Goodhart's Law. Yes, that's the one. I think that we are very much in this dynamic here where, for a long time, we've known that like things like grades are very difficult to get. Like you want learning, like better learning to align with higher grades. You could definitely get higher grades without like doing learning. The correlation is weak, but it is positive, right? So I think the same is going to be true here where, all the incentives are set up so that people are going to be publishing more. Will that, in general, like correlate with things being good? Probably still, but I think that correlation is going to get weaker and the amount's going to go up. Given that if we're just looking at citation metrics and publication metrics and like these types of things, those all benefit just most from publishing more. Yeah.
Yeah, but I fully agree that like I know there's some institutions at least that are known for like, oh, if you don't have a first author paper when you apply to grad school, you have no chance, like we don't even consider you. And I think that's really bad.
Well, now you might have two or three.
Now. Yeah.
I've seen some 2 or 3.
We should really like see because also research already, right, can be so different where like you can have done way more difficult work, but just not everything results in a paper, right? Or like if it's instrumentation or if it's just very, I don't know, it's not, for me, that's not the goal of learning, especially as an undergrad. It's not like try to get you a paper as soon as possible, but like how do we get you the skills and the critical thinking and like.
And people are really stressed out about it.
Yeah.
Yeah. So this is my thing is why I said like the title of the talk was like, what are we doing? Right. I think we have to think really hard about what is it that we are doing, right? Like if this is like the outcome to how do you produce more papers and like get better output? I don't know. Like this doesn't seem like a positive outcome to me. I think thinking about like what is it that we're really trying to do in training people, getting better understanding, producing better quality work, like raising the bar for everyone. I think that's if we can find a way to get there, then things will be better. But yeah, I agree with your concerns that probably this inflation problem is going to get worse before it gets better. Yeah.
Do you have any thoughts on how you would change the incentive structure given the social structure? See, that is a path. Undergrad, you go in 17, 18, you're like 28, 30 by the time you're like at a job. That's a social structure.
Yeah.
Yeah.
No, I mean, the way I always describe it is that academia is very triangle shaped in how the whole system is set up, right? If you just do a simple analysis of like how many students does a professor mentor throughout their career, it's more than about one, which is what you'd want if you just want to do replacement, right? Like, you know, but it's growing. So, okay, great, two. And every professor, it'll double in like, 30 years. Seems pretty good. Like inflation, all things considered, it seems like it's great. But yeah, like if people are expected to have groups of like 2 to 3 students at any given time, typical prof is like, supposed to mentor like 30 students. You do the numbers and you immediately see why like the field is so competitive. Everything is set up to produce more people into the academic pipeline at every stage than it can accommodate at the end. So starting there, I think is like absolutely the top is like the thing. And that doesn't mean that we need to have less PhD students, but I think it means that we have to be very clear in how we design like everything about a PhD to, in terms of who people are, like what people go in with expectations wise, how the programs are structured, what type of relationships we have with, with industry, with other institutions or universities, with other types of careers. That needs to be done like right away. Because otherwise it's disingenuous. And the incentive then will be if you're all fighting over a too small number of things, there's no way out other than just always doing more because you have to always get a leg up on somebody else.
You're essentially already seeing that with the inflation of bachelor's degree.
Yep. And now it's masters, right? So now everyone needs a master's, and now masters is enough, so everyone goes to PhD. Yeah. Yeah. No, I mean it's very much this way, right? So I think
yeah, it makes me also think of also with PhD programs, right? Like right now, a lot of the astro PhD programs, I feel like they're designed around the more classical idea of like, okay, you learn astrophysics, you prepare for maybe a professor career. So like, okay, you need to get all these courses, like way more courses than maybe needed. You need to get all these like exam like things, like just like undergrad or things that you would maybe do as a teacher, like quals or so on. And then it's like, okay, you have to write papers. But it's not so much, I feel like, so it's all these like, okay, do we tick these boxes for like, if you were a professor, you would be ready. If you wanted to become a professor, you're like getting the right skills to get into that path. But it's not so much looking at like what are really the skills that we want to learn, right? Like the kind of more like programming, for instance, like, oh, a certain level of like understanding programming, critical thinking of programming. And that's like not something like maybe some programs have that, but other programs like might not even require any level of programming in their like master's degree or in their PhD degree, which like maybe for some people is okay, right? But like I feel like it's, I don't know, I would like to much more think about like what are the skills that you should learn in like an undergrad program, but in like a grad program when you get like an astro degree rather than like,
thinking of programming, I mean, why do we need to program anymore? Because it's fine. No, I mean,
the critical programming, like
critical
being able
programming,
to understand
yes,
at
yes.
least the baselines of this, right? So like I don't think you need to know anymore like all the. I used to have the programming exam in the like my paper and pen where you have to fill out the like functions by heart.
So
Like that you don't need to do anymore, but
yeah, so I think there are lots of different ways to respond to this essentially. But I think a lot of it starts from first like thinking about what's the incentive structure that's built in and why is it doing this? And if it's always, we're based on these metrics, all of which are correlated with increased publication output, and like the field becomes increasingly competitive because we are shrinking the number of slots without shrinking the number, or in some cases growing the number of like entrants, then you are setting things up for this type of environment, right? It's like a race to the bottom, more or less. And so the best way to stop a race to the bottom is to figure out like how can we set a race that does something differently, set dynamics to do things differently. No one has solved this. I mean, if you want to see what things could look like, go look at CS. I mean, CS is like flooded with like many applicants. Conferences are insane. Reviews for those are crazy now because I think I was seeing like at least a year ago, they were like, oh, this year 30% of our reviewers have PhDs. And I'm like, 30% of the reviewers of these papers have PhDs. Oh my God, like that's terrifying. But they're like, oh, the numbers are up. Like we got this back up, because again, like so many people submitting are grad students, like or master's students or undergrads. And then part of the system they have is that if you submit, you have to review. So you as like someone who maybe you're a postdoc, like you submit a paper, you get 5 reviewers and like 2 of them are undergrads trying to review your paper.
This is also what Belmonts do.
Yeah. I mean, so
also you submit a proposal, get the review some other people's proposal.
exactly. So it's something like this where you can be like, that's the solution they tried to deal with. And now, like, it's AI writing the papers, trying to review the papers, doing all sorts of things to them. So I think that this is not a solved problem, but I think that's sort of figuring out like where are all these incentives coming in and why is it causing this type of behavior? And then what can we do to try and like deal with this is probably like the more important question, at least for what I like to argue here. I think there's also often things about access and equity and what we learned, but I think a lot of them will filter down from all of these. If there's a clear mandate that says, look, we can relieve pressure by having a better relationship with industry, by admitting fewer students, but like doing a better job of supporting the students that we have, these types of things, then like all of those will help to change some of this. But I don't think there's a consensus because there isn't one model that's worked. Yeah.
So I have a bit of a different question.
Let's do it.
But almost everyone in the room, if not everyone in the room, says they like use AI every day or like most of the time.
Yeah, people are using a lot.
Okay, so you could like extrapolate that to like the community.
Mhm.
Yet when I go to the archive and I read papers and I go to the acknowledgement section, and this is kind of, I know Flora, you've been thinking a lot about this with like software citation and stuff. I never see anyone acknowledge the use of Claude or
Yep.
Chat.
I've done it.
It is technically required.
Yeah.
But everyone's using it, but I never see people acknowledging that.
Yep.
And like, how should we do, I know people have been thinking about this in different ways, but like, how do you do that well? Is it like, certain like AAS journals now, it's like you say what the contributions of everyone was. So maybe that's like something like that, the AI helped do X, Y, Z, and NASA actually makes you do this now for like
Yep.
HST or JWST proposals. Like, what do we do to like, it's fine to use it, it seems, sometimes, maybe, I don't know, it's complicated. But like, how do you actually take ownership of that,
So I think a lot of this, again, comes down to our complicated relationship with technology. So I can ask the same question, which says, how many people, list out all of the ADS queries they did to get the papers that they cited?
Mhm.
Right, I think it's zero. We treat it as if it's like a utility, like water, right? Or something that's just so natural, like why would we cite it? We cite software, because we've used it for certain things. We don't necessarily cite, we might say we used ADS. We don't say exactly what we used ADS for, with some exceptions, right? When it becomes important, quote unquote, like if you're doing a literature review, then you say, here's exactly how I got the papers that I used for my literature review. I did the search on this day with these settings and this type of thing. Like I use this tool. We're in a place of change with these tools. And so I think there's definitely an argument that you could make that says like right now, like maybe in the future, people won't cite these tools. But right now, we're not there yet. And so people should be using them in the same way. You should be very detailed about how you use them, the same way that you would if there's a query because of X, Y, Z. But you could also say like we don't necessarily cite Grammarly or autocorrect or lots of other tools that just help improve our Overleaf itself.
Yeah.
Right. Like
And
when
Josh,
writing
you
a
might
paper.
maybe like, so we like,
So yeah, that
Bill
would
and
be my
I
opinion.
recently organized like a workshop that wasn't around software citation, but we actually also talked about like AI citation.
Yeah.
And I think the thinking is very similar, where like also with software citation, like yeah, some people are like, of course you should cite AstroPi when you use it, right? Like even if it's the dependency or so. Whereas there's other people and they're like, no, it depends. Like you should only cite software if you're really using like a package that's like
Yeah.
by an astronomer, but not if it's like something that's like, okay, the whole community has now agreed that like we're using this. And so citation kind of has like lots of different
That's right.
roles. So it has a role of like, okay, crediting. So like maybe, especially like a group like AstroPi, it's now one of the most cited papers in all of astrophysics.
Yep.
And they
Woo.
go with that statement of like, look how many citations we have through like funding agencies to say like, look, we're really important, but we're like underfunded. Like this is a way that they have a metric of saying how important they are. So like sometimes citation can really lead to like funding for those software, for instance. So like that's why it's important. Sometimes it's just
And
like
that's why you gotta
acknowledge it.
produce more papers to the eyes
Yeah.
to get funding.
Sometimes it's like to acknowledge it, so to just
Yeah.
give credit to like the people behind the code to say like, okay, maybe that AstroPi paper has like a first author that did a lot of work but doesn't get to use the same time to write normal papers. And sometimes it's for like reproducibility, right? To really say like, okay, in order to really reproduce all my results, you would have to also use the same version of like AstroPi, et cetera, et cetera. If you really want to, make sure you get like the same thing. And there's all these like gray areas of like to what level. And in some ways it's like up to the community and even sub communities to kind of decide what is the ethical thing to do? Like, what should we do? In some ways, it's up to you. Like, some people cite all the way to like Euler in their.
Yeah,
I've seen it. People try to get the oldest citation in their paper and so on.
Yeah.
People are like, okay, maybe I don't need to cite Euler anymore for like the Euler method.
Yeah, when you reference
like,
the normal distribution, you get to cite Gauss, right?
Right. And so some of this is also style or like personal preference, but I do think I think what's important mostly is like to consider a citation, to know that these things are citable and you can acknowledge them. And then journals will have their own preferences, like communities will have their own preference, but I think like to consider it, right? And so maybe one super quick thing I could share. I can actually kick you out of this one and I think share it like this.
Ooh,
so this is
removed. All right.
I'm sorry. I'm really sorry, but like
I recognize this was done with Claude.
Yeah. So it's also made by AI. So actually we should have a statement.
I recognize exactly the style.
Yeah. So I hope that like maybe there's I hope this also has a recognition of, it's not yet like it's public, but like we still have to kind of wrap up the last things. The one thing you can do is like it try to like kind of think of some of these questions, right? So like that you use something like this, like ChatGPT, or like which that you also can list versions. So this is more for reproducibility, training, etc. But then especially this, so like also what I would personally love to see in papers indeed is like indeed, maybe in the acknowledgement section, if you have space, and usually there is space, there's some journals like Open Journal of Astrophysics that now requires this, where indeed you can like acknowledge like what role AI models play, right? And so I think like things like coding and like editing, like small editing is like a different role than like it reproduced this entire paper. And I think it's a somewhat of a good statement for like discouraging people from like submitting entirely made up papers by AIs or so. But again, it's a very gray area, right? There's no, I don't know, someone could say like, okay, what does it mean to do for validation? Like that can have very different meanings, or writing, reviewing and editing can be very, it can become very like rewriting everything or so.
Of course. So I think like, the answer to this is that I think going exactly what Flor says, I think is the right call. Like this is an actively moving thing. There are lots of ethics involved. And so this is not like a one size fits all answer. However, my position is that it is very likely that in 5 or 10 years, if this tool becomes so ubiquitous that just like with Google, we don't even think about using it to the same extent that we do, it just becomes part of how we navigate the world, which I think is very possible. Then you might see that some of this stuff goes away, the same way that we don't cite every Google search that we did or every ADS search that we did. But I think right now, that is not the case. And so it is important to not do that.
And I will add that like ADS does really like it if you acknowledge them.
Yes, they do.
Like if you cite them, because they also rely on their, but it's not like you're not citing like, oh, here are all my searches, right? You're just saying I made use of ADS for creating this. And I don't even know how much they're using it, but like I think for funding reasons, they appreciate it.
Maybe we should be aware of what the thing is we cite can help their funding.
Yeah.
I think
it's
it's
funding from you. No.
Yeah, and I think you can see, for example, like just this type of stuff, right, is potentially like the things that you can accomplish might change, or the way that you do work might change in the future. I think it's just good to be very open to that. Maybe the ability to, the same way that we often learn how to engage with things by not writing novels, but we read a lot of novels, and we might have lots of opinions on novels and even be able to critique them at a very high level and in very technical place. I think coding is moving in this direction where you might read a lot more code than we write. And that actually might be the way that we learn to code. If we are using these models to do a lot of that code, a lot of students might be very comfortable reading a lot of code. They might struggle to write code themselves, but it doesn't mean that they don't know what the code's doing. Right? Like there's some gap there. Just because you might struggle to write a short story from scratch doesn't mean that you can't read and really enjoy one. So, and being able to make tools like this might become more common, right? This might be a bigger expectation if someone says, oh, I want all the figures in this paper to be interactive, because we can easily make that, because we can do that now. I think that'd be awesome, but also you might say like, oh my God, I have to go to a website, like all these websites that are not maintained to like access everything, and the journals might be like, oh my God, it's a nightmare. So
I don't know if we touched on this in the last website we were just on, but how reproducible are it's a typical LLM? Like, do the context that it has, it's like
great question.
It sounds impossible to reproduce.
So yeah. So actually, if we did the same exercise where I went and ran this exact same query, I would be pretty confident we would get a completely different paper out.
Right. Yeah.
Like not
Totally
even
different,
close.
like science case entirely, right?
Yes.
Probably, okay.
So the reproducibility comes in as a technical aspect and then a more fuzzy one. The technical one is that, yes, part of this is the specific way in which we generate text or tokens from these models, but is that it's done using this top K sampling strategy where you get all the probabilities and you clip them to be within like the top 1000 or something, and then you pick based on that one with some temperature. And that's like a random process. However, even if you had set the temperature to be 0, so it only picks like the most, the biggest one, because of how these models are served and usually how math works on GPUs, especially in large batches, it still would not be deterministic. So even if you tweaked everything right, you controlled the seed, you did all the stuff, you could not get reproducibility from these models, especially not these ones where you don't have access to any of that stuff. So with local LLMs, you might be able to get closer, but with these ones, you absolutely have no idea. Now, what you find though is that often when it generates things like text, some parts are very reproducible. It'll probably write very similar code. The code might do the same thing. Even if it's written slightly differently, it'll give you exactly the same output. And usually what I find happens is that, and this I think is true for intuition, there are lots of parts of things where they're pretty, what you might call like, rote. So once you generate like some sentence, you're like, okay, this is the method section. I kind of need to do X, Y, Z. And so those types of things, even if it's a bit more fuzzy, it will look very similar from run to run. So it'll produce similar looking code that does similar things, that makes similar plots and this type of stuff. But then there are often breakpoints in analysis where you have a very, very broad spectrum of what could come next, right? You finish like one section, you go to the next one. There's a lot of options actually for what you might talk about, say in a discussion. That's not necessarily obvious and could depend a lot on other things for how you did the analysis. It's during those times where I find that often things can diverge. So there's often these breakpoints or like special high temperature areas or very diverse areas in text generation, where those are often where the models will start diverging very quickly. So they'll be fine in like certain choke points, like between those two things, they'll produce very similar structures.